Well, it says M and N are on circle L, so we'll put M and N on circle L. Here's M, there's N, and there's L, because the circle L, L must be in the middle. It says that the angle MLN is 60 degrees, so MLN is 60 degrees. Well, as soon as I see that 60 degrees, I'm going to say that this is also 60 degrees because it's a central angle. All right, then it says I'm supposed to find the area of that sector. Well, the sector is just the area that's defined by these two lines. It is not the whole circle, it's just part of the circle. If I was trying to find the area of the entire circle, what's the area of a circle? Anybody? Pi r squared. So if I wanted to find the area of the entire circle, I would do pi r squared, where r is 20 in this case. I guess I could write that down, that LM is 20. All right, so d pi r squared. That'd be for the entire circle, but it's not the entire circle. I don't care about the radius of the entire circle. I care about that little m2n segment. So that's going to be, to get that little percentage, we're going to do 60 divided by 360. Does anyone have what that comes out to? I can't remember offhand. 6.7? I think 6.7 is right. So it'd be 6.7 pi. That would be the answer for the area of the little sector. Same thing for length. Length goes with circumference. Well, circumference is... Someone? Anyone? Is perimeter, but what's the formula? 2 pi r. So in this case, if I was finding the whole circumference, I'd use 2 pi r, which would be 20. But I don't want the entire circle. I want that small percentage of the circle. The small percentage of the circle would be 60 divided by 360. So once again, that 2 pi r is my total circumference. This 60 divided by 360 gets me that little section of it. And that's going to equal, I know the answer. Oh, wait a minute. This one wasn't 6.7, was it?
No, that was the...
66.7 should have been the radius. Yeah. You guys got me there. So this should be 66.7 pi. This one was 6.7 pi. All right, questions on either one of those? You got to know how to do those. Yes? Say it again. You sure? So I'm just trying to find the area of this little section right here, right? So I find the total area, and I multiply it by the percent of the circle that I'm talking about, which is 60 divided by 360. That gives you the percent of the circle you're dealing with. You sure you don't have a question? Okay. Question of the bell work? Yes?
Wait, so what's like the formula for area?
Pi r squared. Yeah. All right, questions from the homework? Yeah.
For number 14, I don't understand why you can't just do 60 over 360 times 185.
I can't hear you. Sam's talking again. Okay, yeah.
I don't understand on number 14 why you can't do 60 over 360, 60 degrees over 360 degrees times 185 over 1. Because isn't that just how you find output?
Yeah, but remember 2 pi r is our circle length. So you have to have 2 pi r somewhere in there.
Yeah, I did.
So that'd be 2 pi times 180.
But isn't the diameter 180?
The radius is 180. If you look at the circle kind of I did. Ooh, that's really blurry. We'll see if it works. But you can see that the triangle I drew in here, this length would be the radius. And I did solve for the radius being 180. The diameter would be a triangle that reached all the way down here.
Oh, yeah, I see.
Yeah.
Yeah,
So it was the radius, so it was that 2 pi. I see what you mean. Yeah, it was the radius, not the diameter in that case.
Yeah.
Yeah. And some of you might have got 60 pi out. That is correct. The reason why I put it as 188.5 is because, Grant, if I said cut that log 2 pi meters long, you'd be like, dude, just give me a regular. Yeah, you'd pull out your calculator. So in real world stuff, if I'm building stuff, we generally round it to a decimal that, you know, the guys that are working on it can actually know versus having pi in all your answers. So that's the reason why I rounded it. But 65, if you had that, that is fine. The only reason why I rounded it because it's more real world. Yes?
Can you go over how to do it?
Do you have any specific questions?
Just a question on how, like, I just didn't want to do it.
Okay. So number 13, you said, right?
Yeah.
So number 13 is I have to find the distance between the hour hand and the minute hand when it's at 10:20. And we went over yesterday a little bit saying that, well, the hour hand isn't pointing right at 10, it's moving a little bit further. It's a little bit further. So if it was right at 10, it'd be 180 degrees. So the first thing I'm going to tackle is, I'm not going to worry about this. I'm going to worry about what is the distance from here to here in degrees. All right, so I'm not worried about the hour hand just yet. I'm going a little bit further out, so I'm just focusing on this line right here. Here to here. And I want to figure out how long that is, and then I'll add on that little extra bit right here. All right, so the way I did it, there's multiple ways to do this. You could do it with 180, but I dealt with, well, it's a series of 5 minutes, right? It's kind of like 5 minutes, 5 minutes, 5 minutes, 5 minutes, 5 minutes, and that's how many minutes it is between. So I'd like to know how many degrees is 5 minutes. If I go from 12 to 5 minutes, how many degrees did I move? So in order to do that, I thought about, okay, there's 60 minutes in an hour. So we go around 60 minutes. Well, I'm looking for 5 minute increments. So I did 5 divided by 60. In other words, every time I get to 5 minutes, I moved 1/12 around the clock. So if I move 5 minutes 12 times, I'm going to work all the way around. All right, does that make sense where I get the 1/12 from? Well, then I just did 1/12 of 360 since an entire circle is 360. That means every 5 minutes you move 30 degrees around a circle. So if I move, that'd be 30, 60, 90, 120, 150, 180. Well, that makes sense because 180 is up, down. Okay, so every 5 minutes I'm moving 30 degrees. So to move from where this red line starts to where it ends, that would be 1, 2, 3, 4, 5 5-minute increments. In other words, 30, 60, 90, 120, 150. So that red line is 150 degrees. Well, if my hour hand was pointing right here, it'd be 180 because it'd be 30 degrees, but it isn't. It isn't pointing right at it, it's a little bit further. So to figure out how far it moved, I'm going to ask myself, how far around did the minute hands move? Well, they moved 20 minutes out of 60 possible minutes. So your minute hand moved 1/3 around the circle. That means your hour hand moved 1/3 of its way to the 11. So we are now 1/3 of our way through that 30%. Well, that means I have right here, if you look at the left of that circle, right here, that is 10 degrees because the other half of that circle, or the other part of that circle, which is right here, kind of this purple line here, that would be 20 degrees because 1/3 of 30 degrees is 10 degrees. So I have 10 degrees here, I have 20 degrees the rest. So then we just do our 20 plus our 150 equals that 170. Is that a little bit clearer? Okay, good. Other questions? Hands up.
On this one, can you explain how you got the 10 from 1/3?
So this is 1/3. We said that from here to here is 30 degrees. So 1/3 times 30 is 10 degrees. It moved 10 degrees of the way.
Oh, okay. And then you know it's 30 degrees because every hour is like 30 degrees of the clock.
Well, yeah, every 5 minutes is 30 degrees of the clock. Yep. And every hour if you're looking at it that way. Yep. Yep. Other questions? Okay, then we have a little bit of a review, then we have a pretty tough problem we're going to do together, and we'll see how far we can get together. So the beginning is just a review of what we did yesterday. So if you look at our examples, it says the circumference of a circle with radius r. Well, I'm just asking for the formula of circumference. Circumference equals 2 pi r. That is the circumference of any circle is 2 pi r. The next part is, what if I don't want the entire circumference? I just want this little bit right here, that shaded in blue part. That's all I want. I want to know that length. Well, you're going to take your original circumference, which is 2 pi r, and the only difference is you're going to multiply by how much of the circle you're talking about. So how much of the circle is taken up by this shaded area? Well, to find that, you're just going to go x degrees divided by 360. So percent of circle times your circumference gives you how long this blue line is. Well, the same thing's going to happen with area. Our area formula for a circle equals pi r squared. So if I'm looking for just part of the area, so this is called a sector. If I'm looking for this kind of brownish yellow mustard color, I don't know. What do we go with that? What color is this? Orange. All right, orange. Our orange there. That's part of our circle. So the first thing I need to do is find the area of the entire circle and then multiply how much of the circle I'm talking about. Well, to do that, it's just, once again, your x degrees divided by 360. So whenever you're doing problems that deal with like these little sectors, just ask yourself, am I dealing with length? If you're dealing with length, it's going to be circumference. Or am I dealing with area? If you're dealing with area, it's going to be the area formula, pi r squared. And then for each of these, it's just how much degrees your arc is divided by 360. So both of these are almost the exact same formula. You just have to decide, am I looking for area or am I looking for length? All right, then we have two quick problems. I do them for a reason. They should be easy, but for some reason, the first one is reversed order, which throws people off. And the second one is fractions, which throws people off. But I don't want you to get thrown off on the test. So the first example says area of a circle. So that's what that little thing denotes. You see this big A in this little circle right here? Yours is a better circle than mine. Mine has a bad. But you should have area of a circle. That's what that stands for. It says the area of the circle equals 28 pi. Find your radius. Well, area of a circle equals 2 pi r. 2 pi. Hang on. We're talking about area. Pi r squared. So our area equals 28 pi. So we have 28 pi equals pi r squared. I just need to solve for r. So the first thing I'm going to look at is, well, I would divide by pi to get rid of my pi's. So if I divide by pi on both sides, both of those turn to 1, and I'm just left with r squared equals 28. Well, to get rid of a square, you're going to take the square root of both sides. So we're going to go square root of this side, square root of that side. Let's bring this up here. We're going to have r equals the square root of 28. What can I simplify that to? Yeah. It'd be 2 radical 7, correct. So r is going to end up being 2 radical 7. Let's talk about where Ishana got that. Well, you can break down 28 into square root of 4 times 7, which equals 2 radical 7. Don't miss these on the test, guys. Take your time, write your formula out if you're ever stuck. Speaking of tests, we don't get our test back today. Maybe we'll get it at the end of the day. We still have one person that needs to take it. Hopefully I can put it in your mailboxes at the end of the day, but I don't know for sure. All right. Our next one says, if r equals 3/8 centimeters, find the area of the circle. Once again, our formula for area is pi r squared. So in this case, our area is going to equal pi times 3/8 squared. And the reason why I put this down is because people get messed up with fractions and squaring them. When you square a fraction, you are squaring your numerator and your denominator. You're doing 3/8 times 3/8, which is going to be the same thing as going 3 squared over 8 squared. Well, that's going to equal pi times 9/64, but typically we put our number out front, so it'd be 9/64 pi for our final answer. All right, our next one. It looks like we have a lot of space. We have a lot to do in it. So try not to write as big as you possibly can. Try to keep things nice and neat and concise. So try to keep, if you're like me, I write really big all the time. But I'm going to try to keep it smaller this time. All right, so we have a circle circumscribed about an equilateral triangle. So circumscribed means it goes around. So we have a circle going around an equilateral triangle. So let's go ahead and draw a circle, and then we'll put an equilateral triangle inside of it as best we can. Oh, that's pretty good. All right, then it says if each side of the triangle is 18 centimeters, what is the area between the triangle and the circle? So let's go ahead and put our 18 around each of these. So this is 18, this is 18, this is 18. All right, so I want to get the area between the circle and the triangle. Big picture. Big picture, I'm not looking for formulas, but what do we need to do at the very end? What am I going to do at the very end to know I have my answer? CC kind of? Yeah. Yeah, I need to find the circle's area, and I need to subtract away the triangle area. So I need to have a triangle area, and I need to find a circle area. What should we find first? Does anyone have a thought on how to solve either of those? Note, what do I need to find the area of a triangle? Sam? I need a height. What do I need to find the area of a circle? I need the radius. So that means I need to find a radius, and I need to find a height. Who wants, what are we going to do first, Tori? Because you already started it.
The triangle, and you're going to drop an altitude.
We're going to do the triangle first, and we're going to drop an altitude. So we're going to deal with the triangle first. We're going to find the area of the triangle first. And so what I'm going to do is I'm going to draw this triangle again down here. The exact same triangle. So I'm just focusing on the triangle, not the circle right now, where we have 18, 18, 18, and then Tori said drop an altitude. So doot, 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 doot. Remember, this is your height then. All right, so really quick, what I'm looking at right now is a triangle that looks like that-ish. Where I have 9 down here, I got 18 over here, and this is my height. How do I find that height? How do I find that height? Aryan.
Can you use like 30, 60, 90?
We can use 30, 60, 90. Where does 30, 60, 90 come from in this? How do I know I can use 30, 60, 90, I guess?
It's a right triangle.
Because it's a right triangle. I know the 90 degrees, but how do I know where the 30 and the 60 go, I guess?
Since it's an equilateral triangle.
Because it's an equilateral triangle, what are each of our measures?
60.
So this would be 60,
Yeah.
this would be 60, this would be 60, so this one would be
30.
30. Yep. All right, so each of these are 60 degrees. Don't forget about that. So this would be 60 degrees. This one would be 60 degrees. So in the triangle I just drew, we're going to actually have 30 degrees up here, and we're going to have 60 degrees down here. Now, with a 30, 60, 90, the one that crossed from the 30 degrees, that is going to be my S. The one across from my 90 degrees is my 2S. And the one across from my 60 degrees is my S square root of 3. Well, my S is 9. And my other one, my S square root of 3 must equal 9 square root of 3. But remember, that is your height. So we are going to find our area of our triangle first. So triangle, I guess we could put it around the same place. Let's put it right next to it. Let's go area, triangle area is half of base times height. Our base on this one would be 18. And our height is 9 square root of 3. All right, half of 18 is 9. 9 times 9. Our area of our triangle equals 81 square root of 3. Cool, that's important. That's half. I think it was Leon. No, it was CC. CC, you told me it was circle minus triangle, right? So now we have a triangle area. Now I just need the circle area, which means I just need to find a radius. I need to find a radius. This is the toughest part of this problem. Does anyone have an idea of how I could find a radius? Sam?
Did
That's okay. Sorry? It looks like it would be. It's not going to be, and we'll see. We'll see in just a second. Because it kind of looks like it should be, right? But we're going to find out it's not quite that. Well, let's start with something. What's a radius? Half the diameter, which goes from the center of the circle to the other side of the circle, right? So let's go ahead and just put a point in the center of the circle. What color haven't I used? That's a weird color. All right, so it's always a good idea to draw a radius that makes sense with the picture. And what I mean by that is that isn't going to help me. That radius has nothing to do with that triangle that's in there. So what I'm going to do is I'm going to draw something that goes to there. Well, then I'm going to draw, just to keep getting sense of stuff, I'm going to draw it to all 3 of these. We don't need all 3 of them, but we need them to kind of think about what's going on here. Do we all see those triangles that are forming in there? Those triangles each have a radius as part of it. This is a radius, and we have a triangle with a base 18. That's not enough information. If I know one side, I have to know it's a 45-45, or I need to know it's a 30-60-90. We can get a 30-60-90 out of these. And how we're going to do that is, if we picture kind of this blue line disappearing. So I'm going to make that blue line disappear just for a second. All right, just focus on those pink. What's the degree measure of each of these angles? Leanne? Not 60. It's going to be 120. It's going to get us to 60 though, right? It is 120 because it's 120 plus 120 plus 120 equals 360. So each of those weird fleshy looking lines, that's all I can think of right now because it looks just like, anyway. Each of those is going to be 120 degrees. All right, but if I bring out this triangle, this little flat triangle, if I bring out that triangle, let me kind of close off this section saying I'm done with that. That can be my area of my triangle. Now let's bring out this kind of, this triangle here with these lines that's like flat and has that blue line on the bottom. Let's go ahead and copy the same colors. Where this is 18. Well, we said that top angle, this angle right here is 120 degrees. Well, let's drop an altitude again. Let's drop another altitude. Which is going to split that triangle up into a 9 and a 9 on the base. So that's a 9. That's a 9. This is my radius. And this is going to be 60 degrees. So that top angle is actually going to become 60 degrees and 30 degrees. Cool. 60, 30, 90. I have a 9 here. That means I can find my radius. We can find our radius. Now with a 30, 60, 90 triangle, the one across from your 60 degrees is going to be your, someone pick a variable that's not s for this one, x. So it's going to be x square root of 3. And the one across from our 90 is going to be 2x. Well, x squared of 3 equals 9 in this case. So let's start with that. X square root of 3. equals 9 in this case. Divide both sides by square root of 3, and we're going to have x equals 9 over square root of 3. I do need to simplify this by multiplying the top and bottom by square root of 3 times square root of 3. That's going to give me 9 square root of 3 all over 3, which is then going to equal 3 square root of 3. Well, our r value, our radius on this one, equals 2 times x. Well, x equals 3 square root of 3, so 2 of those is going to equal 6 square root of 3. That is my radius. That's important. That's important because now I can find the area of the circle. Circle area is going to equal pi r squared. So area equals pi r squared. Our r is 6 square root of 3 squared. Okay, 6 square root of 3 squared is going to equal 6 times 6, which is 36. Square root of 3 times square root of 3 is 3 pi. 36 times 3 is 90 plus 18, so that's going to be 108 pi. Whew, that's a lot of work. But we're almost done. We're almost done. Let's go ahead and finish this off. I'm going to finish in that bottom box. CC said if I do my circle minus my triangle, I'm going to have my answer. So circle area minus triangle area. Our circle area was 81 square root of 3. Our circle area, I should do my circle area first. I don't know why I did that. We should have our circle area being 108 pi, minus my triangle area is 81 square root of 3. There is no way to push those two together, so that would be your complete answer. I guess I should box it in, so I circled the other ones that were important. All right, so once again, we just did our circle area minus our triangle area. The hard one to get was really our circle area. Although this seems like a very complex problem, every part of this is accessible. Every part of this is accessible. Finding your height, you did this a billion times with these. Drawing a radius that makes sense, you always need to draw to the corners of the shapes that's in there. And then come up with your angles of 120, which gives me a 60, 30, 90. Hamza.
Why can't you divide both of those by 9 and 108 pi?
Because we don't have another side to balance the equation.
Oh, we can't do, okay.
It'd be like saying this building's 300 plus 400 feet. I'm going to divide by 10 and say it's 7 feet.
Okay.
Those are numbers. That's a number you can plug in your calculator. If you divide by 9 or something, you come up with a completely different, right? Because that's like centimeters or something.
Yeah.
If I had another side where it was like that equals x, then we could divide everything. Count.
Why would you multiply by 3 pi? Where did you get 3 pi from?
I got it from here.
Like how?
6 squared is 36. Square root of 3 squared is 3. Because 6 square root of 3 squared is 6 square root of 3 times 6 square root of 3, which becomes 6 times 6 times square root of 3 times square root of 3. All right, questions on that? Like I said, it looks very complicated, but everything in there is accessible. It breaks down to 60, 30, 90 triangles. At the very least, if this was on your test, you should at the very least be able to come up with your area of your triangle, at the very least, and then say, well, if I could find the area of the circle, I would subtract this from that. All right, guys, that's all I have for you today. I'm going to walk around and quickly check